सर
हाँ, यस, ओके सर। अगर कुछ बीच में बंद हो गया तो अगेन आई विल, कभी कभी रिस्टार्ट हो जाता है ना, तो थोड़ा सा पॉज दे देना। एंड नाउ हेडफोन पे मेरा वॉइस नहीं है, आवाज सुनाई नहीं देता, तो ओनली आई विल स्पीक इन हेडफोन। बाकी कुछ प्रॉब्लम हो गया तो जस्ट यू कैन कॉल मी इन फोन, है ना। So, good evening, all the participants. So, this is Dr. Mahesh's law. So, take an example. If the pressure is suppose the 1 bar, okay, and my volume will be equals to 2 cubic meter, and say my final volume, suppose initial, I have to compress the air from initial volume 2 cubic meter to final volume 1 cubic meter, and initial say my pressure will be equals to 1 bar, say atmospheric pressure. Then what will be my final pressure? So my from this formula I can say that my final pressure will be equals to 2 bar. Okay, now come to the main pneumatics. Okay, so in pneumatics there are various types of standards are being used. So the basic standard is my ISO 1219-1 2016. These standards are being used to define the fluid power system and various components. What symbol will be there, what circuit diagram will be there, okay, that is main. So whenever I am giving the marking system, okay, I can show you. So in that case, I am using these standards. Okay, how to mount the various types of component of the pneumatic cylinder. Then these standards are being used. Okay, and for all the hydraulic and pneumatic circuit diagram, we are using CETOP RP41 standards. So like that, there are n number of standards are there, but these 4 basic standards, pneumatic standards, are being used in the pneumatic cylinder, in the pneumatic systems. Now, so pneumatics and say in the pneumatics and control system development, so there are basic components are there. Okay, so that components are, one is the actuators, some inputs and the input devices are being required, some processor are being used, some various types of accessories are used, and the control system are being required. Okay, let's see the flow diagram. So this is the basic pneumatics control system. So initially we require the energy supply. Okay, so energy supply, how I am getting the energy supply? So first I will require the energy from the compressor. So compressed air is stored in the reservoir, so you can use the reservoir also. You can use some pressure regulating valve also. You can use some service unit also. Okay, we will study. Okay, then from this energy supply, the energy or the compressed air is given to the input signal. So that input signal can be various types of valve. That also we are going to study. And from this valve, the return valve, pressure control valve, or various types of primers and sequence. Then after processing the compressed air or the signal, then I am getting the output, or I can say that it is a signal output. So for signal output, again we can use the directional control valve also, and finally I am getting the command execution. That command execution, for the command execution, I have to use the power component, or I have to use the various types of pneumatic cylinder, I have to use the motors, okay, or visual indicators also I have to use. So pneumatic system always follow these flow diagrams. So let's see one by one how the various types of components are being used. So this is the basic component. Supply elements, you can say that the compressor are being used. Okay, then input elements, various types of valves are being used. Then processing element, we can use the directional control valve. Then control unit, also we are using the directional control valve. And finally the power component, we are using the various types of motor or the actuators. Okay, so let's see in detail. So first we can say that this is the typical industrial system layout, or you can say the air generation system. Okay, so now in the air generation system, so you can see that there is a compressor, and the compressed air is stored in the reservoir. Okay, so that compressed air, okay, So this compressed air, then it is being utilized, okay, at the various sections whenever it is required. Now you found that from the reservoir through the pipeline, the compressed air is being supplied to the various units, okay, and these pipelines is always, you will find it is inclined to 1 to 2 degree gradient, because what will happen, the compressed air, when it will get condensed, okay, what will happen, that condensates we can extract out through the condensation unit or the some drain cock, okay, here there will be the drain cock will be there, so that no moisture will get entered inside the system, okay. So this is the main air generation system will be there. Next, we require the air service unit. Now, whenever air is sent to the system, or you can say any actuator or any valve, first it must be well conditioned. So, to condition the air, what we have to do first, so we require first the compressed air filter. So first we require the filter. So this section you can say that it is a filter unit. So in the air, in the atmosphere, whatever the contaminant or the dust particle will be there, that will get filtered out in the filtered unit, okay. Or if any contaminant or moisture will be there, that will get separated and or it is trapped at the bottom by using the filter unit. Then we know that there will be some regulator unit will be there. So this unit you can found that this is called as a regulator unit. So because the whatever the air is coming from the compressor is of high pressure, okay, and in the system, suppose the air coming from the compressor is 7 bar, and in my system I require the 3 bar, okay. So here I can regulate the pressure of the air through air regulator, okay. And then finally here I can check by using the pressure gauge whatever the pressure of the air is required, whether it is regulated or not, that I can visualize by using the pressure gauge, okay. And finally my air, sometimes this lubricator unit will be there, or sometimes in the system lubricator unit is not there. So this portion is called as a lubricator unit. So what will happen in the third unit, if you say that this is a filter unit, okay, then you can, from this knob I can say regulate the compressed air, and this section, second section is shown over here, it is called as a lubricator, okay. So this lubrication is same in the mist form, just like the spray, if you are doing, just given the spray like that, okay. So lubricant is in the mist form is sent to the compressed air, so that when air is passing through the going to the various directional control valve and actuators, okay, that lubricant will lubricate the inner surface of the cylinder and directional control valve. So therefore it will work very smoothly, okay. So that is nothing but the air service unit, which consists of the filter, regulator and the lubricator. So these three symbols can be represented by a single symbol, that is a filter, here it is a regulator, and third one is called as a lubricator, okay. So this symbol is most important whenever for engineer, because he can learn what is the meaning of each and every symbol will be there, and then he can understand the circuit diagram, okay. Next is called as a wall. So there are various types of, say, walls will be there. Just a bit, okay. So there are the various types of walls are being used. Okay. So the function of the wall is to control the pressure or the flow rate of the pressure medium. So depending on the design, my walls can be classified as directional control wall. So directional control wall, in that you can see it is the directional control wall or DC wall can be used as the input element. It can be used as a processing element, or it can be used as a control element. That we will see in details. Then directional control directional DC wall can be a non-return wall. It can be a flow control wall. it can be a pressure control valve, or it can be a shut off valve. So let's see in detail one by one. So first we will see the directional control valve. So directional control valve can be used as the input, it can be used as a processing element, or it can be used as a control elements. Okay, this can be used as. So you can say that the valve, normally the valve can be described by number of ports or opening. You can say that there are the two-way valve. Okay, you can say it's a three-way valve, it can say four-way valve. Okay, in terms of the position, you can say it's a two-position valve, or you can say it's a three-position valve. Okay, and method on the basis of the method of actuation of the valve, we can operate the valve manually, we can operate the valve mechanically, we can operate the valve pneumatically by using the air pressure, or we can operate the valve by using the electrical actuation. Some valves, they are return, so they are having some return mechanism. So they are actuated by using the spring return, or they can actuated by the pneumatic or the air return. Let's see in detail. Number of ports, we can say that say this is one position, okay, and this is say second position. Okay, so this is the two position valve. And how many, say you can say two position valves are there. Okay, so this is a rectangle indicate just a bit. Okay, so this rectangle, let's say two positions, so you can say two rectangles are there. Okay, one rectangle or one square and two square. So you can say this is a one position, you can say this is the two position. If there are three squares are there, then you can say that this is the three-way valve. Okay, if there are four are there, then you can say that it is a four-way valve. Okay, and base your three position valve. Okay, it's a two position valve, and you can say that this is a two position valve, or you can say that this is a four position valve. Then in terms of the opening, you can say two-way valve. Let's see here, there is a here one way, two-way, two openings are there, and here three openings are there. Okay, here also one openings are there, two openings are there, and three openings are there. Okay, so like this, there may be the two-way, three-way, or four-way